Right, past paper questions. The sets. Number one, in a class of 30 students, 20 played cricket, 17 played football, and 7 played both cricket and football. Each student played either cricket or football. Draw a Venn diagram to represent the information and be how many students played cricket only, football only. All right. So the information we were given is a universal set will be the class of students, which will be 30. Let's put C as a subset for cricket, which is 20, and F the subset for football, which is 17, and cricket intersect football, the students who played both would be 7. Right now, this will represent numbers, so it's numbers in the element, numbers in the set, right? Now, the first part to draw a Venn diagram, the universal set is represented by the rectangle. The two sets will be represented by circles. I'll draw them in two different circles to change the color. And so this is a universal set here. So the number of elements in the universal set is 30. Number of elements in set for cricket is 20. Number of elements in the set for football is 17, and the middle is 7. No outliers, right? Now, part B, and I'm not finished with the first part. How many students would have played cricket only would be 20 minus 7, which is 13. And the students who played football only would be 17 minus 7, which is 10. Right? How many played cricket only? Well, I just showed you in the Venn diagram here. So part 1, cricket only would be the total number in the set, which was 20, minus the ones that played both. So 13. Part 2, football only is the total number who played football minus the ones that played both, which is 10. And remember, students. Number 2, in a class of 30 students, 20 like mathematics, 12 like physics, and 6 liked neither maths nor physics. So draw a Venn diagram to represent the information above. Determine the number of students who like both mathematics and physics, mathematics only and physics only. All right. So what information we have? We have the number of elements in the universal set, which will represent the class, which is 30. We have the number of elements in the maths, who like maths, so M for mathematics, which is 21. And the number of elements that like physics, or the number of students, sorry, that like physics, so P for physics, is 12. And we know 6 like neither. So if 6 like neither, they will be outside the sets. And for it to be outside, it will be a composite set. So a composite of maths and physics would be a union of maths and physics in bracket composite. So this will represent the set that is outside, right? So the number of elements in that set, or the number of students are in that set, is 6. So part A, to draw the Venn diagram. Venn diagram is represented by the rectangle, as you know, and then 2 circles to represent each set. Now we label in the Venn diagram, so the universal set will be 30. The number of elements in the mathematics set will be 21. The number of elements in the physics set will be 12. and the number of people who don't like anything will be outside. So let me just fix this a little bit, because I don't have space to draw it on the outside. Let's see how I do that. Okay, fixed, right? So the number of the people on the outside who don't like physics or maths is 12. Oh, I'm sorry, 6. Right? So this is basically the Venn diagram. Now we're not completing the Venn diagram until we finish question B or part B. Why? Because we need to find out who likes, determine the number of students who like both mathematics and physics. So that would be the number inside here in the middle, or the intersection, right? Who like both. Now we have to consider the universal set is 30 students. And if we have, let's call this X for now, 21 students who like maths, this will be 21 minus X for the number of students who like maths only, right? And if this has 12 students, so this circle represents 12 students, the number of students who like physics only will be 12 minus X. That's X, 12 minus X. Now, let's put this in a bracket. This represents one number, this represents one number, X will represent a number, and 6 represents the student outside. Now, if we add this, 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 and this, we should get 30 students. So let's do it. So 21 minus X, add 12 minus X, add 6. And we're doing some simple algebra here, right? If you want to say minus X, add X, but cancel out, right? Remain with a negative X. And we do with the numbers now. 21 add 12 is 33. Add 6 is 39. Right? And we want to solve for X. So I will carry the 39 across. It will become negative. So 30 minus 39 is equal to negative X. 30 minus 39 is negative 9 because we subtract and keep the sign a larger number. So 39 minus 30 is 9. Larger number is negative. And bring down the negative X. Now we're going to divide by negative 1 because the coefficient, when it have no number, is 1. So it's negative 1 divided by negative 1. If I divide on the right, I must divide on the left. And a negative sign divided by a negative sign is a positive. Negative 1 divided by negative 1 will cancel out each other. They give us X. So in the middle here, you'll have 9 students who like both maths and physics. Right? And to determine the number of students, so this will be part 1. To determine the number of students that would like mathematics only, so part 2, maths only, you will take the number of students who like maths, which is 21, and minus 9. So this will be 12. And part 3, physics only, will be the students who like physics, which is 12, minus the ones in the middle, which is 9. And the answer is 3. And again, this is students, right? Now, if you were to check it up, you would see if you're correct, right? So if this represents 12, and this represents 3, 12 add 9 is 21, add 3 is um, 24 plus 6 is 30, which is the total number of students. So that's correct. Now, we have to remember what is the set notation for maths only. So maths only, right, is the set of mathematics students, including, or the intersection between the mathematics students and everything outside here, to get this only. So the maths only section will be the mathematics intersect everything outside the other set, which is P prime, pre-composite. And to give you the number of elements in this set here, let's put the n in front of it, and that will equal to 12. Similarly here, if it's the physics, the P would come first. It'll be intersecting everything outside the other set, which is maths. So maths composite, right? And this will give you physics only. So this statement here means maths only, which is shaded here. And this statement here means physics only, which will be this shaded here. So you have to remember how. So number 3, in a community of 100 people, 31 like to run, 65 like to walk, and 22 neither like to walk nor run. Draw a Venn diagram to represent the information. Determine the number of people who like both to run and walk, to run only, to walk only. All right, so we're going to draw the Venn diagram. Right, so the number of elements in a universal set would represent the community of people, which is 100. We'll have 2 circles because there's 2 groups. So let's call this one R for running and W for walking. So the number of people in the running group is 31, and the number of people in the walking group 65. And the number of people who like both, who like neither, so who not in the group, right? So remember, if you're not in the group, you would not be included in this group here, which is a union between running and walking. So you'll be in the composite. So the number of people in the composite is 22. Right? So this is a basic diagram. Now part B, determine the number of people who like to both walk and run. Right? So that's here and here. Right? So this is run, this is walk. We're trying to find the middle here, right? Which is the intersection. So the correct notation for the middle here will be R intersect W. Right? Now the universal set would contain the number of people who like to run minus, and I'm writing it in set notation now, the number of people who are in the middle. Similarly here, we'll have the people who like to walk minus the people who like to do both. Why? Because this will be the only section, right? So here, add here, add here, add here, right, should give us 100 people. Now, what I like to do is use an x value, because we have numbers here, which is 31 minus x. So here will be x. Here is 65 minus again x, and here's 21. So if I put them in brackets, and we say the total number of people is equal to this, add this, add this. So R minus the number of people who like boots. That'll be the first part, which is the only. I'll put it in a different color. So the number of people who like to run only, add the number of people who like to do both, which is X. Oops. Let me put it in set notation so you will get it. Number of people who like to do both, add the number of people who like to walk only, which is W minus the ones who like to do both. Right. Let me just fix the distance here. And we always have to include people on the outside. So forget my red bracket here. Right, and the people on the outside who don't like to do either, right? So we go to fill it in now. This represents who like to run only, so let's leave it out. Who likes to do both? Who likes to walk only? And this one is neither. Right? And this is everybody. So this is the 100 people. This would represent 31 minus X. You want to do both to represent X, so add X. Add walk only 65 minus X. And you want to do neither, it's 22. Right? So you're gonna do simple algebra again. So say it's 100. And 31 add 65 is 96. 96 add 22, so 96 add 22, 8, 118. And just like before, a negative X add X is 0, or will cancel out. So we have this X remaining, so minus X. And again, you want to solve for X, so we carry the 115 to the left hand side. So we get 100 minus 118 is equal to negative X. So 100 take away 118, you subtract by and keep the larger number, 118 minus 100, which is 18. Keep the negative sign, and again is negative X. And the coefficient of any value is 1 for any variable is 1 when there's no variable in front of it. So you're going to divide by negative 1 on both sides. So this here and this here will cancel to give us positive X. Negative 18 divided by negative 1 is positive 18. So 18 students, 18 people like to do both. All right, so I'm zoom out a little bit so I see everything. And part 2, who likes to run only? And again, the set notation for this will be open bracket. People who like to run intersect people who outside the other set. So the other set is walking, so the composite of walking. And the number of elements in here would be 31 minus X. And we know X just now to be 18. 3. So 3 people like to, no, not 3, borrow 1, 13. 13 people like to run only. And people like to walk only. Again, if you want to find the walk only, put the W first. Intersect the composite of R. So this is the set notation, or your correct set notation, which is 65 minus 18. And 65 minus 18 is 47. So the numbers of people who like to walk only is 47. right? So in the Venn diagram, so if I was to blow it up a little bit, let's blow it up a little bit. I would erase the middle here and write run only, which is 13. In the middle, I'll put 18, and on the right hand side, I'll put 40. Right, so for now, you just leave it like that. But writing the correct set notation, right, will give you the full marks for these questions.
So this,
The So number 4, Venn diagram below shows the number of students who play guitar, G, or the number of students that play violin, V, in a class of 40 students. So the universal set is 40. How many students play neither the guitar nor the violin? So they have the Venn diagram already. So let's very quickly, so we can have it on the screen with us. Doesn't always have to be neat, but the neater you have it, the better the universal set. Here it's 40. And again, correct notation is in number of, right? So we have G, we have 2x, x, and 4. So the students who play neither, or the students who outside, G union V composite is 12 as the students on the outside. Write an expression in terms of x, which represents the total number of students in the class. All right. So if we were to represent the total number of students in the class, we'll have to take here, add it to this, add it to this, and add it to this. So this is just an expression. So 2x plus 4 plus 12. Now, this is an expression. If I was to put equal to 40, then it will become an equation. So the difference between an expression and an equation is the equal sign. Right? So no equal sign is an expression, equal sign is an equation. C. Now write an equation will represent the total number of the students in the class. So again, 2x plus 4 plus 12 will be equal to 40. So this one is the equation. How many students play guitar? So we want to find how many students play guitar. But it didn't say guitar only, so we have to find everybody in the circle, which will be 2x plus 3x, right? 2x plus x, which is 3x. Basically, a solvent from here. So 2x plus x is 3x, plus 4 plus 12 is equal to 40. We want to find how many students will be equal to 3x. 4 plus 12 is 16. If I carry it across to the right hand side, I'll get 40 take away 16. So the 3x would be, is it 14? Borrow 1 from the 4 is 3, 3 minus, no, 24. So the number of students who play guitar is 24. How many students play the guitar only? Now, guitar only, remember the notation for it is G intersect V prime. All right, so guitar only would be 24, which is the whole group, minus the middle. All right. Now, how do we find the middle students? So we know 2x plus x is equal to 24, right? Which is, I don't want to confuse you. All right. So the number of students that play guitar only would be the 2x here, right? So we had to do a little working on the column here. So we're going to find how much the x value is. So if 3x is 24, divide by 3 to give you x. So x is 8. So the number of students that play guitar will be 24 minus 8, which is 16 students. F. How many students play the violin only? Well, this is straightforward. You're reading it from the playing violin only. Number of students that play violin only, right, will be 4. So they give us that in the diagram. And how many students do not play the violin? So how many students do not play the violin? So again, if I were to zoom into the diagram, students who didn't play the violin would be on the outside of the violin set. But it might be easier to just paint the violin set, right? And add everything that's outside.
Out of 12, I get 12.
So
why didn't get 20?
Right. So again, students who do not play the violin will be the ones that are in white right now. So 2x plus 24. We just found out the ones that in guitar only was 16 students. So persons that did not play the violin will be 16 add the 12. It's just 28. Right? So 28 students didn't play the violin. So you could go ahead. So number 5. In a survey of 30 families, the findings were that 15 families own dogs, 12 families own cats, X own both dogs and cats. 8 families own neither dogs nor cats. Given U, the families in the survey, C is for cats, D is for dogs. Complete the Venn diagram below. The universal set, or the number of elements in the universal set, is 30. Number of elements in the family that own dogs, a little bit to see the numbers, is 15. Number of people or number of families that own cats, C for cats, is 12. X amount own both, and 8 was neither, which was outside. So again, the notation will be number of elements in dogs union cats equal, sorry, composite equal to 8. Right? So that will be the Venn diagram for now. Now, the middle here would be 15 minus x. Here, which is cats only, will be 12 minus x. And remember, this wording for here is dogs intersect cats. And I'm not showing properly there, so I'll write it on the outside here. Dogs intersect cats is x. Right. So that's basically a Venn diagram. You could go further into it and write 15 minus x and 12 minus x, because this will give us the amount for onlys, right? So part B.
Okay, sir.
So part B, write an expression in x which represents the total number of families in the survey. So again, our expression is not an equation, it doesn't have an equal sign. And the expression will be 15 minus x, add 12 minus x. We're going to put 1x, but we don't need it. Add 8. Now again, this comes from here, and this came from here, right? Part C, where they say write an equation, you're basically writing this back, but making it equal to the 30. So 15 minus x, add 12 minus x plus 8 is equal to 30. It doesn't matter if you had simplified it or not, you should still get the mark, right? But if you simplify it, it's not a problem. So if you want to simplify the numbers, 15 add 12 is 27, add 8 is 35. Negative x add x will cancel out to give us 0. And then we'll have negative x remaining is equal to 30. And again, well, they didn't ask you to solve here. But this is, okay, so we didn't need to do that as yet. That was the next step. Part D. Where they ask us to solve how many families own dogs only. So basically, dogs only, they want to find this value here, 12 minus x. Now, in order to do that, we need to solve for the value of x, which I was going to do just now. Right? So 15 minus x plus 12 minus x plus 8 equals to 30. We're going to solve it. Make it look like there's a takeaway sign. So again, I got 35 minus x is equal to 30. I carry the 35 to the right hand side, it becomes negative. I'll have negative x is equal to 30 minus 35. So negative x is equal to negative 5. So 35 minus 30 is 5. Keep this any larger number, right? So negative 5. Again, any variable or the letter that has no coefficient, the number is 1. So we're going to divide by negative 1 to make it a positive value. So